Hello students, you are welcome to mathematics class. Compliments of the season to every one of you. Alright, I believe you have copied your scheme of work because that should appear first in your mathematics notes. Okay, if you have not done that, kindly do that. I've sent it on WhatsApp. Yes, WhatsApp group. Go and check. It has been sent. All right, if you look at the scheme of work, if you check it very well, the first week is a revision of what we did last term. Okay, and one of the things that I discovered I gave some of you challenges is transposition of formula and variation. And here we are. I want us to actually iron some things out, some things that I didn't get properly when we are dealing with this topic. When we talk of change of subject of formula, we also talk of transposition. It's still the same thing as saying transposition of formula. If you look at the screen very well, you discover that I wrote that to change or transpose a formula means to rearrange it so that a different letter or symbol becomes the subject. This process is exactly the same as solving an equation. So to change also means to transpose. Let's take for instance, you are given a formula like this: V equals to U plus 8C. Now if you look at this very well, you discover that V comes first, and then they now want you to rearrange this formula. They want you to restructure it and ask you to make U the subject of formula. U the subject of a formula. Of course, what you see there is V as the subject of formula, but this time around they want you to make U the subject of formula. What do? What you just need to do is that you just need to take away every value attached to U such that U will stand on its own, and that is what you have to do. That is as simple as that. So for this kind of question, it's only one step. You don't need to stress yourself. Since U can stand on its own no matter where it is, whether it is at the left hand side or the right hand side, then if you look at this, you see that, oh, here is 8C. Just say, okay, V, move your 8C to the other side. That will be, and remember that when you are moving it, the sign or the symbol will need to change. So it's going to be minus 8C equals to U, which is the right thing. So V minus 8 equals to U, which is the same thing as U equals to V minus 8C. Just one step, you have gotten that. So some subject of formulas are so simple that you just need to take one or two steps and then you are done. The same thing, we can make A the subject of formula for this same equation. Make A the subject of formula. Let's assume that this one we are through with it, and we still want to make A the subject of formula using the same equation. V equals to U plus 80, and we want to make A the subject of formula. What do we need to do? We need to take anything that is representing an obstacle, anything that is attached to this A, we need to take it away such that A will stand on its own, because this time around we want to make A the subject of a formula. So what do we do? The first thing, you cannot just say, oh, we want to remove everything that is attached to A without taking some step. Now the first step here is U. You take it to this side, V minus U, then you now left with a AC. Okay, V minus U equals to 8C. Now since you want A to stand on its own, what do we do next? Then the only way we can remove this T that is attached to this A is to divide by T, and once you divide this by T, it will also affect the second one. Okay, then this will cancel out, so therefore A equals to V minus U over T. So you are true. You are true. So that is it. If I ask you to make T the subject of formula, the same process, just take U to the other side, then divide by A, and then you have gotten what you need to get. So it's as simple as that. And also there are some challenges that students also have, most especially when it comes to square roots. When it comes to square roots, they don't know how to deal with square roots. You as well, listening to me, may not really know how to deal with challenges of square roots. Okay, I'm telling you, it's very simple. You don't need to stress yourself. Look at the question. Take for instance, you are given a question like this: T equals to 2x, let's say 2x square root of x over k. And then in this one you are asked to make let's assume they ask you to make x the subject of formula. X now is the subject of formula. I put it here. S is the subject of formula. So what do you do to this? Okay, what you just need to do to this is that since there is a square root there, you can always take square of both sides. So anytime you see a question in this structure, you can always square both sides. So squaring both sides will help you to remove the roots. Okay, the root is known as the radicals. We call it radicals in mathematics. Something that will not allow you to solve problem if you did not take care of it. So the only way we can take care of roots is to square both sides. So squaring both sides now will enable you to eliminate the roots in the question. So if you want to square t now, here will become t square, okay, then equals to 2x all square, because the square will affect this and this. So here is going to be like 2x all square, okay, and here will be like roots x over k all square. Okay, you can see the way I square it, because this is belonging to another thing entirely. So you square this, you also square this. So this square will now cancel these roots. Okay, and then we have t square equals to 2s square is like 4s square. Okay, and let's say times x over k. So with this now, you can be able to move further. But if you don't take care of these roots, then there will be a problem. Now, when you are done with that, you can now say, okay, t square equals to 4x squared times s is 4s squared x over k. Okay, now you have something like a fraction here. Remember, always remember that you have to make x the subject of formula. You have to make s to stand on its own. Now, since you have a fraction here, you can as well turn this one to fraction. Anytime we have a fraction like this, of course you know, and anytime we have a fraction and there is no addition or no subtraction, maybe we have division, it is good for us to cross multiply. So 4x squared s times 1 is 4x squared s, okay, then equals to t squared times k. That would be, you can say that kt square. Then since we are to make s the subject of formula, the only thing that is blocking this x, or that is serving as obstacles to this s, is 4x squared. So you divide both sides by 4x squared, then here is going to be 4x squared. So because there's no way you divide both sides, this side by 4x squared without making sure that it affects the other parts. So this now, the whole of this will cancel this. So x will now be equals to kt squared over what? Over 4x squared. Oh, you are done. So you can see there is no big deal on this. I will give another one that involves square roots, because most times students always have challenges with roots. Let's assume we are giving p equals to roots 5t over d, and you have to make this the subject of formula. You have to make d the subject of formula, or you have to express d as the subject of a formula. What do? I told you in the previous example that anytime we have roots, you take care of the roots. Even if it is cube roots, you take care of the cube root by cubing both sides. If it is a square root, you take care of the square root by squaring both sides. It's as simple as that. So what do I mean by cubing both sides? Let's take, for instance, we have something like this. Let me just put it here. P equals to, let's say we have cube roots of let's say 6t over d, and then you want to get rid of these radicals. What you need to do is just you cube both sides. You see, cube both sides. Cubing both sides will help you to take care of these roots. Okay, then you cancel, so that this p cube will now be p raised to power 3 equals to 6t over d. Then it will enable you to further with your work. If not, then you won't be able to move on. So let's go back to example 3. So here is square root. You see our square root. So the first thing is we take care of the root. So we square both sides. Square both sides. So square both sides. So here is going to be p square equals to roots 5t over d all square. So this square will eliminate these roots. Then we have p square equals to 5t over what? Over d. Recall we are to make d the subject of formula. Then I told you something that when we have a fraction like this, of course you can make both sides to be fraction by put over 1 here. Then you cross multiply. P square times d become dp square equals to 5t times 1 is what? 5t. Then divide both sides by p square. Dividing both sides by p square, we ensure that you are left with d on its own, since that is our aim, to make d the subject of formula. So this we cancel this. So we have d equals to 5t over p square. So you are done. You see, you don't need to give yourself any headache for solving a transposition of formula, or for making a particular variable to stand on its own. Of course, let me give one more example for change of subject of formula. One more example. I'm going to give example 4. Example 4, the one I'm going to give this time around, let's say we are given an expression. Should I give that? Okay, let's just use this one. Make m the subject. Make m the subject of formula. Formula such that d equals to 1 over 3 m k 1 over 3 m k square. Remember, we have to make m the subject of formula. Solution. Of course, if I'm to write this properly, I'll just say d equals to 1 times mk square is in that's mk square over 3. You can all agree with me. You can check the screen very well. Sorry that is blur. Sorry. Okay, it's showing now. So d equals to mk square, because 1 times mk square is in that's mk square over 3, and we have to make m the subject of formula. So that means m must stand on its own. If you look at this is just like a fraction, just like the one we have been seeing before. So just put over 1 here so that both will be a fraction, then you cross multiply. So mk square times 1, you can start from this side, you can start from the right hand side to this side, and can start from the left hand side to this side. It's still the same thing. So mk square times 1 is a mk square equals to 3 times d is a 3d. Since I'm to make m the subject of formula, the only thing that is standing as hindrance to m is k square. So you divide by k square. So dividing by k square will also affect this one. So it's going to be by k square as well. So here we cancel this. So m equals to 3d over k square. Yeah, true. So if they now, let's say for instance from the question, they now ask you that, okay, take d as let's just say they ask you to take d as let's say 3, and take k as 5. What you just need to do, you just substitute. After you have make m the subject of formula, you just substitute. Now say, okay, m equals to 3 times d is 3, okay, over k. What is k? 5 square. You can see k, just put k is 5, so square is k already. So that will give us m equals to 3 times 3 is 9 over 25. You can leave it in fraction, you can also leave it in decimal, depending on your interest or depending on the question. If it's specified, you should put it in decimals. Alright, we are done with change of subject of formula. I believe that I'm able to clarify you on the change of subject of formula. Also, let's quickly look at one vital part of variation, which I also discovered that you are having challenges with in the first term, and that is partial variation. I'm going to cite just one example here because of the limited time we have, and the question goes to us: the quantity y is partly constant and partly varies inversely as the square of x. The first thing says write down the relationship. Another name for relationship is a connection. You can ask to write down the connection. they can use another word aside the relationship. So between x, in fact, they can ask you to, they can also use the word like a relation between x and y. Then secondly, when s equals to 2, y equals to 9. And when s equals to 1, y equals to 30. Find the value of y when s equals to 4. Okay, all right. I told you they can use the word relationship, connection, relation, any words they use. You should still know that they still bounce down to the same thing. All right, the quantity y, now solution for this, the quantity y, so I write out y. The quantity y, you can always go back to the question. The quantity y is here means equals to, is partly constant. So when they make mention of the part of the word partly constant, then you introduce a constant by yourself. Pick any letter of your choice. So for me, I'm picking A. So y is partly constant, so y equals to A, and partly varies. So plus and here means plus, and in partial variation means plus, and partly varies inversely. Now this time around, I'm using another, since they make mention of the word partly again. Partly constant A without anything. Partly varies, another constant with something. That means of partly varies. Partly constant, nothing will be attached to the letter you picked. Partly varies, something will be attached to the letter you picked. So I'm picking another letter now. I picked A first because they mentioned partly constant and partly varies. So I'm picking another letter too. So I'm picking B now. B. Partly varies. If you can see, partly varies inversely as the square of x. So partly varies inversely as the square of x. Assuming it was partly varies directly, now I will just say bx, but partly varies inversely. So inversely is going to be over square of x, so x square. You can see that is the structure there. All right, so let's move on. Then as I write down the relation between x and y, we cannot get the relationship yet until we are through with everything. So we go to the second one. When s equals to 2, y equals to 9. Y is 9. Okay, let me write the 9 properly. So y is 9 equals to a plus b. S is now 2 square. So 9 will be equals to a plus b. 2 square is 4. Okay. All right, you can see what you can do here is you can just do brief work here, put over 1 here, put over 1 here. 9 will just be equals to s of 1 and 4 is 4. 4 divided 1, 4 times a, 4a, plus 4 divided 4 is 1 times b. So we cross multiply. When we cross multiply, 4a plus b times 1 is 4a plus b equals to 9 times 4, that will be 36. So this one is equation 1. The reason is like this because we are trying to make it a single value. We are trying to make it like this. Assuming it is partly constant, or assuming it's partly varies directly, we don't need to go through this trace. We just put bx square, but it's partly varies inversely, and that was the reason why you need to restructure it in mathematical sense. So that is equation 1. Then the other part there is now going to be, we are still going to follow the same trend. So what is y in the second equation? When s equals to 1, y equals to 30. So it's going to be 30 equals to a plus b over x. This time around is 1, so we put 1 square. So 30 equals to a plus b over 1 square is 1. So 30 equals to, we don't need to go through the stress of the first equation because b over 1 is also b. So 30 equals to a plus b, which can write it as a plus b equals to 30. Call that equation 2. We can now solve it simultaneously. The first equation here is 4a plus b equals to 36, equation 1. The second equation is a plus b equals to 30, equation equation 2. Okay, let me make use of elimination method. So I put minus. I make use of elimination method because I have same value, same sign, plus plus. So minus. So 4a minus a. So I'm taking equation 1 minus equation 2. So 4a minus a is 3a. B minus b. 4a minus a is 3a. B minus b is 0. So 36 minus 30, that is 6. Divide both sides by 3. This we cancel this. So a equals to 2. I've gotten the value of a, which is 2. Okay. Now, to now get the value of b, I will put a equals to 2 into equation, let me pick any equation of my choice. I prefer picking equation 2. Equation 2. So anywhere I see a, I put 2. So equation 2 is a plus. So a is now 2 plus b equals to 30. So b equals to 30 minus 2. B equals to 28. So the value of b is 28. Now, what is now the relationship? I can now go back to that first question. Write down the relationship between x and y. Because if I did not get the value of a and b, there is no way I'm going to write the relationship between x and y. That was the reason why I left it first. And no, trying to solve for a and b, then I will now go back to that equation. So you go back to the first equation there. So anywhere you see a, you put 2. Can see, because it's 2 and 28 that actually connect x and y together, because that was the question. Write down the relation between x and y. So going back to first equation that we generated, which is so y equals to a plus b over x squared. So that's going to be y equals to, what is a? A is 2 plus what is b? B is 28 over what? A squared. So this is the relationship. This is the relationship. The relationship between what? X and y. Between x and y. You can see, very simple, very simple, very simple. One of the simplest subtopic that you need to pick interest in is a partial variation. Please, you can always go back to the video and check any issue you are having. And if you also want to ask questions, you can always private chat me on my WhatsApp number. You all have my WhatsApp number. If you don't have it, go to WhatsApp group and check for my name there, bring it out and ask any questions of your choice. I'm ready to answer your questions promptly. Thank you very much, and don't forget to do your assignment and also to copy your notes on the portal. Notes has been uploaded on the portal. Check it, write it down, and also whatever you can also write out from this video, jot them out in your notes. But one thing is your scheme of work first. It must appear on your notes, because that is the first time I'm going to check when we finally resume to the score. Thank you very much, and enjoy your day.